Our next topic is about cross or vector product of two vectors. So, on chapter 2, meron tayong dot product. For this chapter, meron naman tayong cross or vector product. So, cross or vector product of two intersecting vectors is defined as the product of their magnitudes by the sign of their included angle. So, in formula, product of their magnitudes or the product of the force A multiplied by the force B sine theta multiplied by the n hat. Or sa loob ng ating klase, ang ginagamit natin dito is we have here the Cartesian vector form of our force A cross Cartesian vector form of our force B is equal to the magnitude of force A multiplied by force B sine theta. And then yung n hat na to is our unit vector or also known as our u. Okay? U. In which yung ating u is equal to the position vector r divided by the magnitude. Okay. So, ito yung formula for the cross product. The magnitude of A multiplied by the magnitude of force B sine theta multiplied by the unit vector. So, n hat yung ginamit dito. Depende na rin kasi sa reference book natin. But for us, yung ginagamit natin for unit vector is u. Okay. So, we have here the properties of our cross product. So, cross product, they are not commutative. Ibig sabihin, pag not commutative, A cross B, hindi siya pwedeng i-interchange na maging B cross A. Okay, although they have the same magnitude, but they will now differ in direction. Okay, A cross B is not equal to B cross A. They are not commutative. They have the same magnitude but different in direction. Also, associative when multiplied by a scalar. So, we have here a scalar M here. So, pag dinistribute natin yung ating scalar M, it will be equal to M multiplied by Cartesian vector A plus the Cartesian vector form force B. Or, pwede rin naman na A cross M B. And then, distributive over vector addition. So, distributive siya. So, we have here C, this must be A. C cross A plus C cross B. Okay? C cross A plus C cross B. So, these are the properties of our cross product. Okay? We also have the orthogonal unit vectors, just like sa ating dot product. Sa ating dot product, last time, if we have I dot I, it will be equal to what? 1, diba? Also with J dot J, it is equal to 1, and K dot K is equal to 1. That is for the dot product. Paano naman yung ating cross product? Sa ating cross product, if we have the same unit vectors, let's say I dot I, J dot J, and K dot, cross, I cross I, J cross J, and K cross K, it will now be equal to 0. Okay, tandaan nyo yan. Sa dot product, I dot I is equal to 1, J dot J is equal to 1, K dot K is equal to 1, or same unit vectors will be equal to 1. Dito naman, if we have the same vector, it will be equal to 0. Okay. Also, I cross J is equal to K, J cross K is equal to 1, and K cross I is equal to J. And J cross I is equal to negative K, K cross J is equal to negative I, and I cross K is equal to negative J. But I have a technique here para hindi na natin i-memorize yung mga orthogonal unit vectors na to. Okay. So, we have, anong pagkakasunod? We have I, J, K. Okay. Yung cross product ng magkasunod na unit vectors will be equal to positive. So, ano naman yung difference nila is just the, ayan, I cross K, diba? Negative J. Tingnan nyo yung K cross I, positive J. Ano lang yung difference? The sign. Tingnan nyo, J cross K is equal to I. What about K cross J? Will be negative I. So, yung kanilang sign conventions or yung kanilang sign is different. Ano? So, sabihin natin dito, magkakasunod na I, J, K. Pag kinukuha natin yung I cross J, it will be equal to positive K. J cross K will be what? Positive I. And then K cross I K cross I will be positive J. So, paano yan? Pag magkasunod sa ganong direction, positive. Pero pag kinuha natin ng pabaliktad, magiging negative. What I mean here is, pag ganun tayo, I cross J magiging positive K. Pero pag kinuha natin na pag ganun, J cross I magiging negative K. Kuhanin natin ng pag ganun. We have J cross K magiging, pag ganun yung direction natin, J cross K magiging positive I. So, paano pag kinuha natin pabaliktad? K cross J will be equal to negative I. Okay. So, ito naman, IJK, pwede ituloy-tuloy natin dyan, maging IJK ulit yan. Kaya naging, yan, K cross I magiging positive J. Okay, ganyan yung direction natin para kahit hindi na natin i-memorize to, ano? Kahit hindi na natin i-memorize. So, ulit natin. So, we have K cross I magiging K cross I magiging what? Positive J. Pero pag kinuha natin pabalik, magiging I cross K magiging negative J. Okay. So, yan yung technique para hindi na natin i-memorize yung ating orthogonal unit vectors para mas mapadali yung pag-conceptualize natin, no? You just need to understand kung saan nanggaling yung ating orthogonal unit vectors. So, no need to compute for that. No need to memorize that. Tandaan lang natin yung lahat ng pag ganon will be positive. Pag kinuha naman natin pabaliktad, it will be negative. Okay. So, for the cross or vector product of two vectors, it will be equal to the determinant. So, dito na papasok yung ating matrix. A cross B. It is equal to the determinant. Okay. Pag sinabi natin equal to the determinant, or the expansion of the cross product, so we have here, okay, let's for example, nasa board tayo. So, this one, bold letter A here is just equal to A na may arrow sa taas, di ba? As I have introduced to you before. Okay. So, kunin lang natin yung Cartesian vector form. We have here AXI plus AYJ plus AZK. And then, cross product, meron tayong BXI plus BYJ plus BZK. Okay. So, time to expand here. I-expand daw natin itong ating Cartesian vector form. So, just distribute. So, we have AXI cross of BXI plus AXI, okay, cross BYJ. Next, AYJ cross of BXI. AYJ cross BYJ plus AYJ cross of BZK. And then we also have AZK cross BXI cross of BZK. Okay. Ngayon, apply natin yung orthogonal unit vectors natin dito. We have here, ano to? I cross I. Sabi natin, lahat ng same unit vectors will be equal to 0. I cross I, so it will be 0. Ano ba? J cross J. Yan, J cross J will be 0. And K cross K will be 0. Okay? So, this one, meron tayong IJ. So, we have here positive K, di ba? I cross K, we have negative J. Then naman, J cross I is negative K. And then, J cross K will be I. Diba? And then, K cross I will be J. K cross J is negative I. Okay, so time to distribute or palitan natin yung mga values ng, or sign conventions natin because we already have the unit vectors. Therefore, A cross B will now be equal to AX BY AX BY minus AX BJ minus AY BX plus AY BJ, positive ion, AY BJ. So, yung IJK natin will determine the sign. Okay, will determine the sign. Next one we have here, AJ plus AJ BX minus AJ BY. Or, sinabi natin dito, it is equal to the determinant. It will be equal to the determinant. So, pag sinabi natin determinant, we have here AX, AY, tsaka AZ, BX, BY, tsaka BZ, and then IJ. So, pag sinabi natin determinant, guys, A cross B equal to, kukunin lang natin yung determinant by using yung tinatawag nating basket rule. So, sa basket rule dito, susulat lang natin yung this one is the Cartesian vector form of our force A, Cartesian vector form of our force B, and then yung IJK. So, pag sinabi nating determinant, kokopyahin lang natin yung first two columns. So, we have here AX, BX, tapos I, and then AY, BY, tsaka J. And then, dito na tayo ngayon mag-a-apply ng basket rule na tinatawag. Okay, so erase lang muna natin dito para may space. Okay. Pag sinabi nating basket rule, unahin natin dito. Kunin lang natin yung diagonal. Oh, sorry. Gamit tayo ng ibang kulay para sige. Okay. So, sa basket rule, kukunin natin yung product nito. Yung diagonal. Dapat tatlo yan. Tatlo. Kunin mo yung product. Then, kunin mo din yung product nito. And then, product nito. So, pag sinulat natin, we have A cross B. So, magkakaroon ngayon tayo ng AX, BY, tsaka K. So, again, yung K natin will determine the direction. Plus AY, BZ, tapos I. Plus AJ, BX, tapos J. Okay. So, dine-determine lang yung directions. And then, lahat nito is plus. Kita nyo, plus yan, plus. Tapos, minus, yung product naman, dito. Okay. Minus na, pag papunta tayo dito. We have here AJ, BY, tapos I, plus AX, sorry, minus. Kasasabi ko lang eh. Minus AX, BJ, tapos J, minus the product of AY, BX, tapos K. Nakita niyo yung pattern. Lahat ng papunta dito will be plus. Addition or sum of all the forces papunta dito. And then, pag papunta na tayo dito, pababa na dito to the left, magkakaroon tayo na rin ng minus. So, plus, minus, the product of this one plus the product of this one plus the product of this one minus the product of this one minus the product of this one minus the product of this one. Okay. Therefore, kita nyo dito, AX, BY, positive AX, BY. Diba? AY, BZ, AY, BZ, positive siya. Oh. AY, BZ. And then AZBX, AZBX, positive, AZBX, tapos minus AZBY. AZBY, ayan o, minus, parehas. Minus AXBZ, AXBZ, minus, parehas. Then AYBX, minus. That's why the expansion of the gross product A cross B is equal to the determinant. So, ito yung tinatawag nating determinant. By using the basket rule or by using the matrix. Okay? So, proceed tayo sa next. We have the scalar triple product. So, naulit lang. Okay, tanggal na to. So, proceed na tayo dito. The triple scalar product involves the dot product of a vector, let's say A, and the cross product of two vectors, say B and C, and it is written as A dot B cross C or B cross C dot A. So, involved na rin dito ngayon yung ating dot product. So, dito sa scalar triple product, okay, kukunin lang natin yung cross product ng dalawang forces. Let's say yung B cross C. Uunahin natin yung cross product bago tayo mag dot product. Ibig sabihin, complete muna natin to B cross C bago natin i-multiply or kunin yung dot product with A. Kaya nga dito, nakikita natin na nagiging B cross C muna bago nating i-multiply into its dot product A. Okay, hindi po pwedeng A dot B muna, tapos yung product ng A dot B, tsaka natin i-cross product with C. Hindi po pwede yan. Okay? Cross product muna, bago dot product. Okay. Or kung isulat natin sa blackboard to, magiging A. Dapat naka-unit, naka-Cartesian vector form lahat ng ating forces. Nakita nyo, gumamit tayo dito ng bold letter. Therefore, it signifies that we will be using Cartesian vector form. Okay, Cartesian vector. So, expressing all the forces into their equivalent Cartesian vector form. So, here, A dot B cross C or B cross C dot A is equal to the expansion or magiging ganito. So, paano nangyari ito? So, i-compute nga natin yan. Paano nag-derive ng ganyan? Yan. So, ilipat lang natin dito. Derive natin itong formula na to. Sabi natin kanina, unahin daw natin yung cross product. So, unahin natin yung D cross. So, this will be the Cartesian vector form of our force vector A. This is the Cartesian vector of our force B, and this is the Cartesian vector of our force C. Unahin natin to, B cross C. So, for the B cross C, sabi natin kanina, gamit lang tayo ng determinant or yung matrix. So, we have here Bx, By, tsaka Bz. And then Cx, Cy, Cz, tapos I, J, K. Then, i-copy natin yung first two columns. So, we have bx, bxi, tsaka by, cy, tsaka j. Kunin natin yung product nito. Product. So, we have here bx, cy, k, plus by, cj, I, plus bj, cx, j. Minus, this one. Minus natin to. Minus bj, cyi, minus bx, cj, j, minus by, cx, j. Okay. So again, kailangan nating kunin yung equivalent dot product with A. So, meron na tayong cross product ng B cross C. Next is to have the dot product at A. Sulat ko na lang dito. Okay, dot product. Dot product na tayo ng B cross C. So, copyin lang natin to. Okay, yan, sakto. Di ba sabi natin last time, yung orthogonal unit natin for that product, I.I, J.J, and K.K is equal to 1, di ba? And then all product of the similar unit vector will be equal to 0, di ba? 0 na lahat yan. Therefore, pwede na nating idiretso. What I mean is, ang kukunin na lang natin is yung product of the same vectors. So, for dito, AXI, ano yung kukunin natin? Siyempre, yung may I na lang. AXI, ito. Kasi ang gagawin natin dito, device, i-distribute natin lahat yan. Distribute. Pero magiging 0 din naman yung karamihan dyan. Therefore, ang gagawin natin dito is, tignan na lang natin kung ano yung kaparehas ng I. Of course, I din. So, we have AXI. Cross product niya will be EY, CJ, I. Diba? I. Next, ano ba? We also have here minus. Pwede nating ilabas yung I. Minus EJ, CY. Ayan. Tapos next, yung J natin. So, we have AYJ. Cross of, hanapin natin yung may J yan. BJ, CX, ano ba? J. Yan. Minus BX, CJ. Tapos CJ. Tapos J. Plus yung may K naman. K, yan. BX, CY. Ano pa? Minus CY, CX. Tapos yung K. Ayan. So, we have I.I will be 1, di ba? I.I is 1, J.J is 1, and then K.K is 1. Therefore, magiging AX BYCZ minus BZCY plus AYJ BZCX minus BXCZ. Sorry. Tanggalin na natin yun. J may J pa. Wala na. Kasi J na will be equal to 1. Plus AZ. Tapos BXCY minus BYCX. So, ito nga yun yung sagot sa A.B cross C. Okay? So, makikita nyo. Parehas pa. We have AXBYCZ. AXBYCZ minus BZCY. Yan. Plus AY. BZCX minus BXCZ plus AZBY. B blah 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 blah. Ayan na. Parehas, di ba? Ayan. So, dyan galing yung derivation of our A.B cross C. That is the scalar triple product na tinatawag. Scalar triple product. Okay? So, proceed na tayo sa moment of a force about a point. So, this one, involved na dito yung 3-dimensional na pagkuha ng moment. Although, applicable pa rin naman to sa 2D. Pag sinabi nating moment of a force about a point, okay? The moment of a force at point O is equal to R cross F. So, again, pag nasa board tayo, this is equal to R unit vector R cross the unit vector or the Cartesian vector form of our F. So the moment at O is just equal to the cross product of the position of vector R by the Cartesian vector form of our force F. Okay, again, position vector R cross product of the Cartesian vector form of our force F. So, we have here our illustration. This is our force F. The R is the position vector drawn from point O to any point lying on the line of action of F. R is a position vector drawn from O to any point lying on the line of action of F. Okay. So, ito yung ating force F natin. Yung kanyang position vector daw is any from the point of action or line of action of our force F. So, ito yung line of action ng ating force F. Extend natin yan. Line of action nga. Extend, extend. Hanggang dun. Ayan. Basta, nasa line of action yan. The position vector R daw, na kukunin natin is anywhere from the line of action of force F. So, ito yung ating position vector R. Pwede rin na ito yung position vector R. Pwede rin to. Pwede dito. Pwede dito. Pwede dito. Pwede dito. Pwede rin doon. Okay. So, the position vector R is drawn from point O to any point lying on the line of action of force F. Okay? So, yung ating position vector R is anywhere along the line of action of our force F. Okay. So, pwedeng magkaiba-iba yung pagkuha natin ng position or value ng position vector R. Okay, so that is the moment of a force about a point O. It is just equal to the position vector cross product of the Cartesian vector form of our force F. Next, we also have the moment of a force about a line or axis. So dito na involve yung ating 3-dimensional moment of a force about a line or an axis. Dito, we have a force F. Sabi natin kanina, yung position vector R natin can be drawn anywhere from our moment center O to the point anywhere on the line of action of force F. So, yung R natin ulit dito can be anywhere along the line of action of our force F. Okay? Pwede dyan. Pwede rin dito. Pwede rin doon. Basta anywhere on the line of action of our force F. So dito, the moment of point O along x-axis will be equal to position vector R cross Cartesian vector form F multiplied by, or the dot product of the unit vector along x. And then the moment along y will be using the unit vector along y, and then ganun din sa z axis. Okay. So this is now the application of what? Scalar triple product. Scalar triple product. Cross product muna bago dot product. Okay? So kukunin muna natin yung position of vector R, tapos i-convert natin yung ating force into its equivalent Cartesian vector form. Tsaka natin ita-dot product with its unit vector. Okay? Therefore, the representation of our moment now is equal to moment xi plus myj plus mz, or the moment at point O is equal to the moment at x plus moment y plus moment z. Naka-vector siya kaya merong I, J, K. So for our example number 1, this is just the same example. Pagkuha natin ng moment using components. Okay? As I have said a while ago, there are many steps or many ways on how to solve for the moment. So this is the third one. So una is yung x and y component, and then yung pagkuha ng tangential and normal component of the force. And then the third one is by determining the moment using cross product. Okay, same sample lang kanina. So dapat magkaparehas yung sagot nung nasolve natin kanina versus this one. Okay. Determine the moment of the force F, which is equal to 40I plus 80J Newton about point O. Ang sabi natin kanina, the moment is equal to the position vector R cross of the Cartesian vector form of our force F. So magmo-moment tayo sa point O. We need to determine the position of vector R. So, ang sabi natin kanina, position of vector R is anywhere from point O to the line of action of our force F. So, ito yung line of action ng ating force F, right? Force F. So, yung ating position vector R is pwede dito, pwede dito, pwede dito, pwede dito. Okay. Pero ang importante kasi dito is we need to take into consideration yung points given. Okay, so kailangan meron tayong distinct coordinate na present sa line of action para mas mapadali yung computation natin for the position vector R. So for this example, saang point may given na coordinate? Saang part ng line of action of force F? Diba dito? We have here a coordinate here. So ano yung coordinate dito? We have here 360, and then y-axis is 150. So meron tayong coordinate yan. Of course, the origin is 0, 0. So ito na ngayon yung magiging position of vector R natin. So the position of vector R is just equal to the head minus tail. The head will be A, and then the tail will be the origin. Therefore, we have 360I plus 150J. And then for our force, the Cartesian vector form is already given. So we have 40I plus 80J. So, ang gagawin natin dito is to apply the matrix or yung tinatawag nating basket rule. So, unahin natin dito. So, we have 360 tapos 150, and then the Z, of course, is 0. And then we have here 40, 80, of course, 0 din yan. And then we have I, J, K. Copy the first two columns. So this will be equal to Pag ganun muna, di ba? The product of this one. Product, minus product, minus the product, minus the product, di ba? So, dito meron tayong 360 multiplied by 80k. Tapos dito, 0 yan, no? 150 multiplied by 0 is 0. So, plus 0. Same also this one. 0 yung product. And then dito, minus 0 din, di ba? 0 yan, minus 0. Minus din dito. Yan, minus 0. Tapos dito, we have minus 150 multiplied by 40j. Here. Before we have 360 multiplied by k. We have 28,800 k minus 6,000 j. Oh, k. The last one is k dapat. Okay. Yan, 150 multiplied by 40 multiplied by k. K yan, this is also k. Therefore, this is equal to 22,800 k. Diba? 22,800 k. Therefore, the moment is equal to 22,800 k Newton dot millimeter. Okay, 2,800 k Newton to that millimeter. This will be the final answer. Also, hindi naman sinabi dito sa problem if we will be determining the exact magnitude. Pero pag magnitude yung hinahanap, tanggalin lang natin yung k, ano? Tanggalin lang natin yung k. So, that is the final answer. Pag magnitude, 22,800 Newton dot millimeter. Dito kasi hindi naman sinabi, determine the moment of the force F. So, wala namang sinabi. Therefore, we can leave the final answer as it is. Okay? The moment of O is equal to 2,800 k Newton dot millimeter. Next, a bar is bent and loaded as shown in the figure. Determine the moment of force F about point O. So we have here a bar that is bent and loaded with a certain force F that has a value of 875 Newton. Okay? So determine lang natin yung ating force or yung ating moment referring to point O. Ayan. So again, the moment at point O is equal to the position vector R crossed by the Cartesian vector form of our force F. Okay. So start na tayo. For this one, hanapin lang natin yung position vector R that is lying to our line of action for the force F. Okay. So dito, extend down natin yung line of action natin. Extend. And then, hanapin natin yung point kung saan meron tayong distinct coordinate from point O hanggang line of action of our force. So dito, sa ating problem, makikita natin that we have a certain given na mga dimensions. Therefore, pwede natin gamitin yung what? Point A. Point A. Kasi given na yung coordinates dyan. Although, pwede mo naman kunin dito sa part na to, dito na sa part na to. Or even dito. Pero, wala kasing given na coordinates. So, dito tayo, utilize natin yung mga given coordinates. Therefore, the position vector R na gagamitin natin is ito. Ayan. Position vector R. Which is equal to OA, diba? So, O is, of course, 0, 0, 0. And then, for A, X natin dito will be 200 y 250 z is 150. Okay, so head minus tail tayo. Head will be A and then tail will be O. Therefore, we have 200I plus 250J plus 150K. Okay, so yan na yung ating position vector. Next is to convert our force F into its equivalent Cartesian vector. So, paano pa natin kino-convert? We have force, the magnitude, multiplied by the unit vector. Unit vector. So, anong unit vector niya? Diba itong point na to? Tsaka ito. Let's say this is point B. UAB. In which yung ating UAB is equal to the position vector RAB divided by its magnitude. So, kailangan natin i-determine yung coordinates ng ating B. So, B will be, X will be 250 plus 150. So, we have 400. Ay, X pala. Sorry. X will be 200 plus ito, 75. So, we have 275. Y is yung 250 tsaka 150. So, we have 400. And then, Z is 150 plus 140. And that is equal to 290. So, 290. Okay. So, head minus tail ulit tayo. Head will be B and then the tail is A. So, 275 minus 200, we have 75. I. 400 minus 250 is 150 plus 150 J. 290 minus 150 is 140 plus 140 IJK. And then the magnitude is square root of 75 squared plus 150 squared plus 140 squared. So the unit vector now is equal to, pwede natin i-diretso. Okay, diretso na lang natin. So we have here, the Cartesian vector form of force F is 875. Tapos, 75I plus 150J plus 140K divided by 75 squared, 150 squared, 140 squared. So this is equal to we have 300.4 I, no? Tapos, plus 600.8 J plus 560.75 K. So, ito na yung equivalent position, equivalent Cartesian vector form of our force F. Therefore, we are now ready to have the moment. Is equal to R cross F. Okay. R cross F. So, copyhin natin. So, we have here 200 I plus 250 J plus 150 K cross of 300.4 I plus 600.8 J plus 560.75 K. I-apply natin ngayon dito yung ating matrix by using the basket rule. No? So we have moment at O, 200, 250, tapos 150, tapos 300.4. Spacing natin para hindi tayo malito. 200, 250, tsaka 150. 600.8, 560.79. And then, of course, yung ating I, J, K. And then, copying the two columns. Okay. So, again, ganun lang ulit. No? Ayan. Plus, plus, plus. Tapos, minus, minus, minus. Okay? So, we have 200. Diretso ka na. So, we have 200 times 600.8. So, we have 120, 120, 160, K plus 250 multiplied by 560.79, 140, 197.5 I plus 150 times 300.4, 45060 J. Okay, dito na tayo minus 9120 I minus 158 J minus 75100 K. Okay, so combining like terms, 140, 197.5 minus 9120. We have 50077.5 I. Tapos next is J. J is 112158 minus 67098 J. Tapos yung K natin, we have 120, 160 minus 75100. 45060 plus 45060 K. Determine the moment of force F about point O. So, yan yung Cartesian vector form niya. The unit will be in Newton dot millimeter. Newton dot millimeter. And if we want to express it into its Newton dot millimeter, so we have 50.08 I minus 67.1 J plus 45.06 K Newton dot meter. Sorry, Newton dot meter. Okay, so hindi naman sinabi dito kung express natin into its equivalent magnitude. So, pwede na siguro to. Pero pag hinahanap yung magnitude, okay. Okay. This one is naka Cartesian vector. So, dapat ito naka Cartesian vector din pala. Sorry. Cartesian vector din. Kasi naka IJK siya, di ba? So, pag sinabi nating moment naman, kukunin lang natin yung square root of 50.08 squared plus 67.1 squared plus 45.06 squared. Okay, so, yan yung magnitude. Dito, hindi kasi clear sa hindi clear sa problem kung pinapahanap is the magnitude or the moment itself na naka-Cartesian vector. So, we can leave our final answer as it is. Naka-IJK siya. Pero pag magnitude, kukunin nyo lang yung square root of the vectors. Okay? So, pag magnitude, the answer will be 95.08. 95.08 Newton dot meter. Okay. Pag magnitude hinahanap. Again, hindi kasi clear sa problem kung naka-Cartesian vector ba or naka-moment or naka-magnitude sa. So, we can leave our answers like this one. Okay? Next. A 534 Newton force is applied to a lever shaft assembly as shown in the figure. Determine the scalar component of the moment at point O about line OB. Kukunin daw natin yung moment at point O about line OB. So, this is now the application of the scalar triple product. Okay, bakit? Because dun sa scalar triple product kasi, we are determining the moment about an axis. Hindi na lang tayo magfo-focus sa X and Y axis. Itong topic na to. Scalar triple product is the application used for the saan na yan? Yan. Moment of a force about a line or axis, diba? So, the application of the scalar triple product is for the moment of a force about a line or axis. So, dito sa moment of a force about a line or axis, hindi na lang tayo tumitingin sa X and Y axis. Pwede na nating i-refer yung ating moment at a given axis. Dito sa problem na to, pinapa-determine yung moment of a certain force, anong axis? About line OB. So, ito na yung magiging working axis natin, yung OB. Okay? So, this is the application of a scalar triple product. Our force here is 534 Newton. Okay, so this is a lever, and then ito yung shaft. So, this one is used to siguro tighten or loosen yung ating shaft here. Okay? So, kaya nag-apply sila ng certain force, which is equal to 534 Newton. So, kailangan lang natin i-determine yung moment of this force at point O in the reference of line OB. Dito yung ating axis ngayon. So, if we will express our main formula here or our main equation, working equation here, the moment of force F at point O will now be equal to what? So, it will now be equal to C. Pinapahanap ito scalar. So, kailangan muna nating kunin yung position of vector R natin cross by the force F. Tsaka natin i-dot product yung line of axis. Yung line of axis natin is OP. So, that will be our working equation. Okay? Scalar, kaya ganito yung ating symbol for the moment. Ang lalabas na dito ng sagot is the magnitude itself. Okay? Magnitude na yung lalabas dito. Hindi na siya naka-IJK. Okay, so unahin natin yung ating position of vector R. The position vector R, sabi natin kanina, it must coincide with the line of action, di ba? Anywhere at the line of action of our force F. So, ito yung line of action ng ating force F. So, dito, pwede tayong maglagay ng position vector dito sa point A. Ayan. Pwede rin dito sa ating, let's say, point C. Ayan, point C. So, pwede rin natin kunin yung position vector kasi nandito yung line of action ng ating force F. Hirap lang mag-drawing ng straight dito. Okay. So, this is the line of action of our force F. So, pwede natin gamitin yung position vector at point A. Pwede rin dito sa point C. Okay, kasi nasa line of action pa rin naman yan ng ating force F. So, ito ngayon yung position vector R natin. Pwede rin naman to. Okay. So, isa lang yung or dalawa yung pwede natin gamitin dito. But, iisa lang yung compute natin for this problem. So, if you want to prove na same sila, it's either of point A or point C yung gagamitin nyo, pwede. Okay, solve natin yung point A and then it's up to you if you want to solve using the point C as the position vector. Okay, so point A tayo, sa point A tayo. Again, pwedeng A, pwedeng C. So here, the position vector R is OA. So A, the coordinates of A is what? We have 275. Y is 350, Z is 0. And then, of course, yung ating origin is 0, 0, 0. Head minus tail. Ito yung gagamitin nating R, position vector R. So the head is A. So we have 275I plus 350J plus 0K. Okay. And then for our force F, ang given dito is the magnitude. Therefore, kailangan natin siyang i-convert into its equivalent Cartesian vector form by having F multiplied by the unit vector. So, ano yung unit vector natin dito? Saan nakalay yung ating force F? It is what? Point. Dating iburahin yan. So, yung ating force F is lying at what? Point C papuntang point A. Therefore, kailangan din natin i-determine yung coordinates at point C. So, at point C, we have here 325, Y0, Z is 400. The head will now be what? A. So, we have A minus C. R, so this is AC. RAC. Diretso na natin. Okay. So, yung ating Cartesian vector form for force F, ano yung F natin is 534. So, again, this one is equal to position vector AC divided by the magnitude. So, pwede natin i-diretso. A minus C tayo. A will be the head. So, we have 275 minus 325. Negative 50. I. Tapos, 350 plus 350J minus 400K. And the magnitude is 50 squared plus 350 squared plus 400 squared. Okay. So this will now be equal to we have negative 50.014 I, tapos next plus 350 350.0096 J minus 400.11. Okay. So, ito na yung equivalent Cartesian vector of our force F. Now, determine natin yung ating unit vector for OB. So, again, ida-dot product natin yung reference axis. Okay? So, this one is yung kinompute natin kanina na R cross F. Same through with the last examples natin kanina. Diba? Ito lang yung kinocompute natin. So, ang difference lang niya is ida-dot product lang natin yung ibibigay niyang reference axis. Okay. Same procedure just like our previous example. Ida-dot product lang natin with the reference axis. So, ang reference axis dito as stated in the problem is line OB. Okay. Line OB. Determine natin yung coordinates of point P. So, X is 275. Y0, Z is 150. Okay. Head minus tail, so we have here 275. Diretso na natin. UOB again is the position vector of OB divided by the magnitude. Okay? So, 275I minus 350. Ay, sorry. O pala. 275I plus 150K. 0 yung J niya. K. All over. Square root of 275 squared plus 150 squared. So, this is 0.878 I plus 0.479K. Okay. So, meron na tayong unit vector for OB. So, it's time now to do the matrix. So, our moment at point O is equal to R. What is our R? This one. We have, again, I, J, K to dapat sunod-sunod yan. So, we have here 275, 350. Yung K niya is 0. Diba? Okay. Next is for our F. F natin we have here negative 50.014. J is 350.096. And then we have negative 400.11. And then dot UOB. So we have 0.878. J niya is 0. K is 0.479. Okay. Na-present ko ba kanina yung matrix nito? Mukhang hindi. Balikan natin. Ayan. So, this is the determinant or yung matrix. Okay, so ganito yung format natin. So, ito yung magiging position vector R. Ito yung ating force F. Tapos, ito yung ating ay, mali. Baliktad tayo. Baliktad. So, dito, ito yung ating position vector R. And then, ito yung ating force F. Tapos, ito yung ating unit vector. Kasi yung format dito is A dot B cross C. Okay, so, pwede yung kanina that you have B cross C dot A, diba? Kagaya nito. Sabi dito, scalar triple product. Yan. B cross C dot A. Kaya yung ating format dun sa kino-compute natin is nauuna yung U. Nauna ba yung U? No, nauna yung R. Sorry, nauna yung R. Tapos F. Tapos yung unit vector. So, yung R natin will be the B. This is C and then A. Kaya yung magiging format is B cross C dot A. Okay? Ito yung format na sinunod natin. So, balik na tayo sa problem. Nasaan na? Okay. So, ito yung ating R, F, tapos U. Then, ganun ulit. Copyhin lang natin. So, wala nang I, J, K dito. 0.14 and then 0.878. Tapos, 350, 350.096, tsaka 0. Okay. So, ganun din. Same. Multiply, plus, multiply, plus, multiply. And then, ganun. Okay. Okay, so this will be equal to, okay, diretsuhin na natin. So, 275, tapos 350.096,479. So, that will be equal to 46116.396. Tapos ito, minus minus 350 multiplied by 400. So, we have 0.878 negative 122,953.8. Okay. Tapos dito 0 na, plus 0, dito rin 0, minus 0, minus 0 din dito, no? Minus 0. Tapos dito we have here 350, negative 50.014 and 0.479. Okay, negative 8384, tapos minus pa, so magiging plus 8384.85. Okay? So again, this is minus tapos negative 8384 kasi yung lumabas. Kaya plus. Therefore, the final answer will be okay, negative. The moment at O is negative 452.55 Newton dot millimeter. Okay? So this is the final answer. Scalar po yung hinahanap. Kaya meron tayo negative 68452.55. Okay, for our last problem here, if f1 is equal to 100i minus 120j plus 75k and f2 is equal to negative 200i plus 250j plus 100k, determine the resultant moment produced by these forces about point O and express the result in Cartesian vector form. Okay, so we have here two forces na. Involved na yung two forces dito, no? Involved na yung two forces. So what we will do is to find the moment at point O. So we have here two procedures or two ways to solve for the moment at point O. Unahin natin yung first step. So una is by determining the moment at point O by using F1 cross yung kanyang position vector R, of course, plus yung F2 cross yung kanyang position vector R din. Okay. So this is the first step. And the other step is by having the resultant cross of R. So, unahin natin tong step na to. Okay. So, problema lang naman natin dito is the position vector. Kasi given naman na yung Cartesian vector form of our forces. So, yung R lang. Okay. So, we have here F1 and F2. They have distinct point. So, yung F2 natin, yung kanyang position vector R or yung kanyang line of action, sorry. Pwede natin i-extend yan. And then also with F1, ito yung kanyang line of action. Ano? So they are coinciding at the same point or crossing at the same point. So can we assume that the position vector R of F1 and F2 are the same? Let's say this one. Diba? Ayan na yung magiging position vector R ng dalawa. Why? Because F1 and F2 are intersecting at a common point. And we can assume that the line of action of F1, let's say this one, ayan. And yung position vector natin is intersecting din dito sa point na to. Also with F2, ito yung line of action niya. Magmo-moment tayo sa point O. So, pwede natin gamitin yung same position vector. So, isa lang yung gagamitin natin position vector dito. So, we have here O, A. So, our A is X natin dito is 4, Y 5, Z is 3. Okay. X is 4, tapos 5, 3. Okay, so that is now the coordinates of A. And then, of course, O natin is 0, 0, 0. So, the position of vector R is equal to 4I plus 5J plus 3K. Okay. Therefore, the moment at point O is equal to F1 natin. We have 100I minus 120J plus 75K crossed by 4I plus 5J plus 3K. And then plus yung ating F2. F2 natin is negative 200I plus 250J plus 100K. Cross with the position vector R na 4I plus 5J plus 3K. Na? So, dito, apply nyo natin yung basket rule. 75. Tapos ito, we have 4I. Ay, sorry. 4 lang pala. 4. Tapos 5. 3, and then we have I, J, K. Basket rule, we have 104 I, negative 125 J, plus, ito naman, yung basket rule natin, ito dalawang to. So, we have negative 200, 250, tapos 100. 4, 5, 3, I, J, K. Okay? So, ito na yun yung ating matrix. So, ganun din ulit. Pag ganun. Tapos to minus Yan. So, adding two determinants and also this one. Pag ganun din later on. So, we have here. Pwede nating idiretso na. So, we have 500 K. 500K plus negative 360I. 75 times 4, 300 plus 300J. Tapos dito minus 375 minus 375I. Tapos minus 300J. Tapos dito negative 480 minus negative 480K. Tapos dito naman plus dito rin we have negative 1000K. Tapos dito plus 750I plus 400J. Tapos dito negative 600 minus negative 600J. Ay, nandito na ako. Dito pa pala. Pagpasensya nyo ng sulat ko, no? Maliit kasi itong ating space. So, inuna ko to. Pwede ito. Nakalimutan ko. So, we have negative 500I. Tapos dito we have minus 1000K. Okay? So, combining like terms. Ito yung para sa ating unang determinant or unang matrix. Tapos ito yung pangalawa. So, same lang naman. Combination of the two matrices. So, combining like terms, lahat ng I muna. So, we have negative 360. Ano pa yung I natin? Minus 375. Ano pa? I. This one, plus 750. Minus 500. So, we have negative 485. I. Tapos lahat ng J. So, we have 300. Minus 300, 0. Tapos dito, 400. Tapos, negative 600. So, we have 1,000. Plus 1,000 J. Tapos yung K, 500. Plus 480. Minus 1,000, 1,000. Minus 2,000. So, we have negative 1020. Negative 1020 IJK. So this is now what? Pounds. That. So this will be now the final answer. Negative 485, tapos negative plus 1,000, negative 1020. Okay, so this is for the first step. Okay, first step. Or the first way to solve for the moment at point O. So, gamitin naman natin yung resultant. So, this is much easier compared dito sa ginawa natin. So, for the resultant, okay, for the resultant, gamitin naman natin itong procedure na to. So, kunin lang natin yung resultant of R. So, sabi natin resultant is F1 plus F2. So, F1 natin yan, and then F2. So, diretsuin na natin. So, 100 minus 200. So, we have negative 100I. Negative 120 plus 250. So, we have, ilan? Plus 130J. Tapos, plus 175K. Okay. Meron naman na tayong position vector R. So, yung resultant natin, pwede rin nandito. Hindi natin alam kung saan yung distinct position. Hindi naman importante yan kasi yung ating position vector is just the same. Ibig sabihin, if we have here the resultant, pag in-extend natin yung line of action ng resultant, di ba? Iisa lang yung common point ulit nila. Therefore, we can use the position of vector R na 4i plus 5j plus 3k. So, ayan. Makakompute na natin agad-agad yung ating moment. So, using the basket rule again, 130 tapos 175 tapos dito naman is 4, 5, 3 and then we have I, J, K. Okay, so this is much easier dun sa compared dun sa nauna. Okay, so we have here negative what? Negative 500K plus 390I, diba? Tapos 175 times 4, 700 plus 700J. Next, minus minus 875I. Tapos minus minus, so magiging plus 300J. Tapos 130 times 4 is 520 minus 520. Okay, so combining like terms, we have 390 minus 875. So we have negative 485. Negative 485I. Tapos J natin plus 1000J. Next for K, we have negative 1020K. Bounce that. So this will now be the final answer. Okay? So pardon my handwriting here. Pangit talaga. Okay, so that ends discussion for the cross product. So if you have questions, you may message or approach me at the department or sa group chat natin for the clarifications. Okay, so thank you and good day.